Today we're going to take a look at negative exponents. So there's another video before this that you should make sure you watch with just dealing with positive exponents and the rules with that. But in this video, we're going to deal with negative exponents. So negative exponents, the simple rule here, if I have something like a to the negative 2, what we'd want to do then is we'd want to rewrite this with a positive exponent. So if I have a to the negative 2, and whenever you just have a number or a variable, it's always over 1. So if I have a to the negative 2, the way I'd rewrite this with the positive exponent is I'd bring it down to the denominator. So it would become 1 over a squared. Now I'm not flipping the fraction. That's always a common misconception here, that you're flipping the fraction, because I had it as a to the negative 2 over 1, and then it became 1 over a squared. I'm not flipping anything. All I'm doing is I'm moving it down to the denominator. The reason I have 1 on top is because this was technically a 1a to the negative 2. So I'm moving the a because that's the only term to the negative exponent, so that's coming down to the denominator. Where now on top, I just have that coefficient of 1 left on top of 1. So if this was like 2a to the negative 2, let's say, what you would do to rewrite that one is you would take the a to the negative 2 and you'd bring it down to the denominator, so it'd be 2 over a squared, not 1 over 2a squared. The 2 is not negative. In order for the 2 to move down, it'd have to be 2a to the negative 2. Sorry, not like that. Whoa, why is my eraser so big? It would be 2a to the negative 2 like that. So the whole statement of 2a is being raised to the negative exponent. So in this case, the entire numerator, everything, because that's all being raised to the negative exponent. So you'd have 1 over 2a now raised to the second power. And then you'd use your exponent rules and everything like that. But let's go through some examples of rewriting negative exponents into positive exponents, because we never want to leave a exponent negative. That's like leaving a fraction unsimplified. We don't want to do that. So we want to simplify this, writing with positive exponents only. And number 1, I have 5 to the negative 3. That is 5 to the negative 3 over 1. So I'm going to rewrite that by bringing down the 5 to the third on the bottom. So I have nothing left on top because I brought the 5 down. So I need a placeholder of 1. So it's going to be 1 over 5 to the third. And for now, I'm not going to, you could, rewrite this as 5 to the third, which is 5 times 5 times 5, which is 125. But I'm just going to leave it as 5 to the third for now. We'll get to the simplifications a little bit later. Number 2, 6x to the negative 2. So x to the negative 2 is the only term being raised to the negative exponent, just like how I was talking about the differences between here and when we'd move something and we wouldn't. So in this case, I would leave it as 6 over x to the second. Only the x has the negative exponent, so the x has to go down to the denominator, and the 6 stays on top. Number 3, 2 over x to the negative 3. So on this one, I have x to the negative 3 in the denominator, so the x to the negative 3 needs to come up this time, because I have to write it with the positive exponent. So if it's negative on bottom, it needs to go up. If it's negative on top, it needs to come down. So the x is going to move to the top. The 2 is not moving anywhere because it's just a 2. So I'm going to have 2x to the third. And you could technically write this as over 1 if you want, but you don't have to. You could just leave it as 2x to the third, which I'm going to leave it alone as just 2x to the third. Number 4, negative 3 raised to the negative 2. So here's the key. The entire statement of negative 3 is being raised to the negative 2. So everything needs to come down, just like how I was talking about here. 2a to the negative 2. That's the same thing as negative 3 to the negative second. So that's going to be 1 over negative 3 to the second power, because then what happens is that's negative 3 times negative 3. Not negative times 3 times 3. That's negative 3 times negative 3. So that's going to be, I'm pretty close to my camera. That's going to be 1 over negative 3 times negative 3 is positive 9. So that actually simplifies down to 1/9. Be careful on that one. Where if I just had this, that's going to be a different story. That's going to be only the 3 coming down to the bottom, where that negative is going to stay on the top. So just be careful with the signs there. Just like when you had the difference between like negative 3 squared and negative 3 squared. We talked about that before. Previous videos, the differences of that, same concept. All right, moving on. So number 5, x to the negative 4, y to the negative 2. So I have x to the negative 4 over y to the negative 2. So first of all, the variables are different. One's an x, one's a y. Second, they both are negative. I have x to the negative 4 on top, y to the negative 2 on bottom. So they got to flip around. X to the negative 4 needs to come down, because that is going to make it positive if I bring it down. Y to the negative 2 needs to come up, because that's negative on the bottom, so now it needs to come up. So I'm going to have y to the second over x to the fourth. So everything's flipping around there. Number 6 is interesting because now we have the same variable. I have x to the negative 3 over 5, or x to the fifth. So I have the same variable, where on number 5 I didn't have that. I had x and y, so I couldn't simplify that. So now we have to understand our exponent rules. If I have x to the fifth over x to the second, our exponent rule for division is when we're dividing by the same base, we subtract. So this is going to become 5 minus 2, which is 3, so x to the third. Use the same rule. But now that we have a negative exponent, there's two ways of thinking about this. You can do the big exponent minus a small exponent, or you can do top minus bottom, and then you'd have to work around it. So I like doing big minus small. So I'm gonna take the big exponent minus a small exponent, and then wherever that big exponent is, that's where I'm gonna write my answer. Where the top minus bottom method, if you use the top minus bottom method, then you're gonna do negative 3 minus 5, and then you'll be left with negative 8, and then you have to rewrite it on the bottom. But if you do big minus small, look what happens. If I take the big exponent of 5 minus a small exponent of negative 3, 5 is bigger than negative 3, so I do 5 minus negative 3, that becomes 8. So then I'd be left with 1 over x to the 8th, because the big exponent was on the bottom. 5 is bigger than negative 3, 5 was on the bottom, so I get x to the 8th in the denominator. Now if you do that top minus bottom method, let me just show you that. If you do top minus bottom, if you did negative 3 minus 5, negative 3 minus 5 is negative 8, so then you'd have x to the negative 8. Well, x to the negative 8 is a negative exponent. I can't leave it as a negative exponent, so I'd have to bring it down to get 1 over x to the 8th. You see how we get the exact same answer? Just two different methods. It's completely up to you how you'd want to go ahead and manage that. I like big minus small. I'm probably going to do big minus small in these videos here, this video. So number 7, I have x to the first over x to the negative 3. 1 is the big exponent, so it's positive 1. The other one's negative 3. 1 is bigger than negative 3, so I'm going to do big minus small. 1 minus a negative 3 is positive 4. Where's my big exponent? Big exponent is in the numerator, so I'm going to rewrite this as x to the fourth in the numerator. If the big exponent was in the denominator, it'd be 1 over x to the fourth. But in this case, it's just x to the fourth because the big exponent was on top. Number 8, a fraction of 2/5 raised to the negative 2. So we have this whole fraction being raised to the negative 2. Whenever you have a whole fraction like this being raised to a negative 2, what you have to do is you have to do this. This is just one way of doing this. If you have a fraction being raised to a negative exponent, you can take the fraction, flip it around, so it becomes 5/2, and then make that exponent positive. From there, it's just power to a power, so this becomes 5 squared over 2 squared. This is going back to previous videos. 5 squared over 2 squared is going to be 25 over 4. And that's not the key for this video. The key is right here, this step from here to here. So let me just explain this one more time and give you a little bit more background of how that works and why that works. So if you go back to power to a power, technically this is 2 to the first, 5 to the first. So what I would do is I would take power to a power, so I do 1 times negative 2, so this becomes 1 times negative 2 is negative 2. 1 times negative 2 is negative 2, so 5 to the negative 2. Well, what happens? 2 to the negative 2 over 5 to the negative 2, different bases, so this would come down, this would come up. So I'd be left with 5 squared over 2 squared. Look at that. Same exact thing. So that's why I like to just go with, if it's a whole fraction like that being raised to a negative exponent, flip it, make the exponent positive, and then do your power to a power. Number 9, we have this whole statement being raised to the negative 3, so we have power to a power again. In a scenario like this isn't the same as if this was all in parentheses like over 3z or something, you know, where it's all being raised to the negative 3, then you would just flip it around and then make that positive. This is not the same scenario because I just have one line. I have a 2x to the third, y to the negative 2 being raised to the negative 3. So what I would do here is I would just raise everything to the negative 3. I would just multiply those exponents. So this is 2 to the first. So this becomes 1 times negative 3, which is 2 to the negative 3. And then I'd have x to the 3 times negative 3. So I'm doing 3 times negative 3, which is going to be negative 9. And then I'd have negative 2 times negative 3, which is going to be positive 6. Negative 2 times negative 3 is positive 6. After I do that power to a power everywhere, I now have to rewrite some things. I have 2 to the negative 3. That's negative exponent. X to the negative 9 is a negative exponent. So those need to come down. But y is going to stay where it is because that's a positive exponent. So I'm going to move this down. I'm going to move this down. But I'm going to leave y to the 6 where it is. So y to the 6th over 2 to the now positive 3. Whoops, I just wrote 8 because 2 to the 3rd is 8. But I'm just working ahead a little bit in my head there. So that's 2 to the 3rd. And then this is x to the 9th. So then I would rewrite 2 to the 3rd as 8. So y to the 6th over 8x to the 9th. And number 10, I have 3 to the negative 2 over 3 to the negative 4. So I have the same base of 3. I have x to the negative 5 over x to the 3rd, same base of x. Y to the 2nd over y to the negative 3rd, same base of y. So we have same number being raised to the exponent here, 2 same variables. So we have to simplify, and then we could deal with the negative exponent. So I'm going to do this, big minus small, this, big minus small, this, big minus small. So I'm going to treat each of the 3, and then we'll combine our answers at the end. So 3 to the negative 2 over 3 to the negative 4. Big exponent is negative 2, because negative 2 is bigger than negative 4. So big minus small. So negative 2 minus a negative 4. That's going to be negative 2 plus 4, which is positive 2. Where's the big exponent? The big exponent is here because that's 3 to the negative 2. Negative 2 is bigger than negative 4. So I'm going to get 3 squared on the top. Now let's deal with the x's. So the big exponent is 3 minus a small exponent of negative 5. 3 minus a negative 5 is 8 because that becomes 3 plus 5, which is 8. Where's the big exponent? Big exponent is in the denominator this time. So that's going to become x to the 8th in the denominator. And y, big minus small, so 2 minus a negative 3, which is going to be 5. Let me not do this in red. 2 minus negative 3 is 5. Where's the big exponent? Big exponent is on the top. 2 is bigger than negative 3, so I'm going to get y to the 5th on the top. The only simplification that I can make is that 3 squared. 3 times 3 is 9, so 9 y to the 5th over x to the 8th. Good set of problems there. Let's keep moving. So I grabbed a couple more for this. This is a really tough concept when simplifying these exponents, so that's why I grabbed quite a few examples. So on number 11, I have negative 2 x to the 2nd, y to the negative 6, all over x to the negative 5, y, all being raised to a positive 3. So notice this is a positive 3, so I don't need to flip any sort of fractions or anything. Just yet, at least, because it's a positive exponent. So let's deal with the inside, and then we will raise everything to the 3rd, see what happens, see how it shakes out. So first of all, the coefficient of negative 2, I don't have anything to simplify that with, so I'm going to leave that alone for now. I have x to the 2nd over x to the negative 5th. That could be simplified because I have the same variable. So I'm going to do big exponent of 2 minus a small exponent of negative 5. 2 minus the negative 5 is 2 plus 5, which is 7. Where's the big exponent? Big exponent's in the numerator. So x to the 7th, x to the 7th on the top. The y's now. So the exponent of 1 on the y. 1 minus negative 6. 1 is bigger than negative 6. So I'm doing 1 minus the negative 6, which is, again, 1 plus 6 is 7. So I get 7 again. Where's the big exponent? Big exponent's in the denominator. So y to the 7th is going to go in the denominator. And that is all being raised to the 3rd. Now I still have to take everything to the power of 3. So this is going to become negative 2 to the 3rd, 1 times 3, x to the 21st, and y to the 21st. So that's going to become negative 2 raised to the x to the 21st, and y to the 21st. Fun problem there. Number 12, I have a fraction being raised to a negative exponent, the whole entire fraction. So let's flip and then make this a positive just to knock that out. And you could knock out a couple steps at one time, but I'm just going to take it step by step. Also, when I'm rewriting this as a positive exponent here, I'm trying to rewrite that with a positive exponent, and I know you might be thinking, well, what happens with these negative exponents? Since I'm rewriting it, I'm flipping it around. Well, I'm treating this negative exponent first. I'm dealing with this -2 first. So I'm going to leave these exponents as is. I'm going to move them, but I'm dealing with this negative exponent. This whole statement being raised to the -2. So I'm not flipping any signs or anything like that. Leave them as negatives, but move them because we are just dealing with that -2 first. So this is going to be 6x to the -7, y to the 10th, over 2x to the -3, y to the -10. Now this is all being raised to the +2. Now we could just use our base rules. We're dividing by the same base. We subtract, here we have 6 divided by 2 is 3. So that's just going to be 3. Then I have x to the -7 over x to the -3. So big exponent of -3 minus small exponent of -7. So -3 plus 7 is 7 minus 3, which is 4. Where's the big exponent? Big exponent's on bottom. So x to the 4th. And then the y's, big exponent of 10 minus a small exponent of -10. 10 plus 10 is 20. Big exponent was on the top, so y to the 20th, all being raised to the 2nd. Now we just deal with the power to a power. So I've taken care of all of my negative exponents, so this has become 3 to the 2nd power, y to the 40th, x to the 8th. Wait, what happened to my x? X to the 8th. Why did I not write that? Okay. So 3 squared is 9, y to the 40th over x to the 8th. And there it is. Number 13. Moving along. These problems are good problems. 3x to the 4th all being raised to the 3rd times x to the 1st all over x to the 15th. So we have this little mix up here with the power to a power. So let's take care of that first. So 3 to the 3rd, because that's a 1. 1 times 3. And then x to the 12th times x to the 1st over x to the 15th. 3 to the 3rd is 3 times 3 times 3. So 3 times 3 is 9. 9 times 3 is 27. So 27. Then I also have x to the 12th times x to the 1st. That's going to be x to the 13th over x to the 15th. And then I have 27 over x to the big minus small. 15 minus 13 is 2. Big exponent in the denominator, so x to the 2nd in the denominator. And finally, last one for this part of this section here. Notice this one on 14. This parentheses is being raised to the negative exponent. This parentheses is being raised to the negative exponent. The entire statement isn't all being raised to the same exponent. It's this being raised to the negative exponent and then that being raised to the negative exponent. There's, even for all of these problems that we've done in this video, there is no shortage of ways that you could solve all of these problems, but I'm just showing you what I find to be just the most straightforward, safest route, trying to knock out all those negatives and everything. But you can do this however you want. So the two options you have is you can do this. This is one option. You could just do -3 to the -3, x to the -3, y to the +15, then distribute it down here. That's one option. Another option is to just flip everything around. So this comes down, this comes up because they're all being raised to the negative. So I'm going to go with that route. So 3x y to the -3 being raised to now +2 because I moved this up to make that positive. And then this is coming down, -3xy to the -5th. That's going to come down. So -3xy to the -5th now being raised to a +3. Now that I did that, it's a little bit simpler because now I just have this all being raised to a +2, this all being raised to a +3. So I'm not worried about all these negatives flying around. This is going to become 3 squared, x squared because 1 times 2, and y to the -6 because -3 times 2. And then this is going to be negative 3 to the third. And x to the third and y to the negative 15. You could have probably been okay if you just wrote this as negative 3 to the third like that, but I just played safe by just putting that in parentheses, but you can kind of go about that however you want. I would rewrite this and then simplify. I know it's going to be a little bit of overkill, but the negative makes me nervous at times because some weird things can happen with negatives. So I'm going to rewrite this as 9 over 27, negative 27. And then that's going to simplify down to 1/3 either way, because negative 1/3 because of the 3 and 2. But I like to show that process more than anything, especially with coefficients like that, because that gets kind of tricky for some people. So I'm going to go over here. This is going to be negative 1/3 x to the second over x to the third. 3 minus 2 is 1. Big exponent minus small exponent. 3 minus 2 is 1. Where's the big exponent? Big exponent's on bottom, so x to the first. And then negative 6 and negative 5, so big minus small. Negative 6 is bigger than negative 15, so that's going to become negative 6 plus 15. 15 minus 6 is 9. Where's the big exponent? It's on top, so y to the 9th. Tough problem there. That was tough. A little tricky. Got to be careful with that one. Okay, that's going to do for this one.